Hi, welcome to Light Class. In this session, I will discuss how to calculate a theoretical yield in a problem. This is a problem given over here, and it states that in a chemical reaction, 42.6 gram iron chloride reacts with 34.2 gram sodium hydroxide to produce iron hydroxide and sodium chloride. The question asks to calculate the theoretical yield of any of the products formed in the reaction. These are the four simple steps we follow to calculate theoretical yield. Let's follow the first step. It says that write the balanced chemical equation. Iron chloride is the first reactant, and let's write the chemical formula of iron chloride. The symbol of iron is Fe, and the Roman numeral shows that Fe has +3 charge, and chloride ion has negative charge, and we balance their charges before we combine these ions. We crisscross their numbers to balance their charges, and here we get the chemical formula, that is FeCl3. This is one of the reactant in the reaction, and it says that it reacts with sodium hydroxide. The chemical formula of sodium hydroxide is NaOH, and so they produce iron hydroxide. Fe has +3 charge, and hydroxide ion has 1 negative charge, and before we combine these ions, we balance their charges, we crisscross their numbers, and here we get the chemical formula of iron hydroxide, that is Fe whole thrice of OH. This is one of the product formed in the reaction, and another product, that is sodium chloride, and the chemical formula of sodium chloride is NaCl. This is a chemical reaction taking place, and we balance this equation now. First, we balance the Cl atoms. On the left side, we have 3 Cl atoms. On the right side, we have only 1 Cl atom. That's why I put 3 before NaCl. Number of Cl atoms are balanced. Now, we balance number of Na atoms. On the right side, we have 3 Na atoms. On the left side, we have only 1 Na atom. So that's why I put 3 before NaOH. Number of Na atoms are also balanced. We check if the number of OH group are balanced. 3 moles of NaOH has 3 OH groups, and iron hydroxide has 3 moles of OH groups. Number of OH groups are also balanced. This is a balanced chemical equation. We are done with the first step. Now we move on to the second step. It says that convert the mass of these reactants into moles. Well, the mass of these reactants is given in the problem. Here you can see that mass of iron chloride is 42.6 gram. Here we have 42.6 gram. This is the mass of iron chloride, and the mass of second reactant, that is 34.2 gram. 34.2 gram. This is the mass of another reactant, and we convert the mass of this reactant into moles. When we convert the mass into moles, we always use molar mass. Then we look for the molar mass of these reactants. Well, the molar mass of iron chloride is 162, and the unit is gram per mole. Well, we divide the mass of iron chloride by its molar mass. To get moles, we use the calculator. The mass is 42.6, and it is divided by its molar mass, that is 162. This is the value we get, but we get this value with least significant figures. If we look at the mass of this reactant, you can see that the mass is given with 3 significant figures, 1, 2, 3, 1, 2, 3. That's why we pick up this value with 3 significant figures. 0 is a leading 0, that's why it is non-significant figures, and 1, 2, 3 up to 2 we have 3 significant figures. Now we look at the digit next to 2, that is 9, and 9 is greater than 5, that's why we round up 2 to 3. The value which we get, that is 0.263, and remaining digit becomes 0. Here we have 0.263. These are the moles of iron chloride. In a similar way, we convert the mass of sodium hydroxide into moles. Well, the molar mass of sodium hydroxide is 40.0 gram. 40.0 gram per mole. We divide these numbers to get moles. We divide the mass is 34.2, and it is divided by 40.0, and this is the value we get. It has already three significant figures. Here we get 0.855. These are the moles of sodium hydroxide given. Well, these are the moles of these reactants given in the problem. We are done with the second step. Now we move on to the third step. Well, it says that use the mole ratio to find the limiting reactant. Before we calculate a theoretical yield, we have to find the limiting reactant in the problem. Well, now we calculate the number of moles of these reactants required in the reaction by using mole ratio. Let's say we calculate the number of moles of iron chloride, and so for this step we use the moles of next reactant, that is sodium hydroxide, and then the mole ratio. Let me show how. Well, the moles of sodium hydroxide are given, that is 0.855 mole. I mention here 0.855 moles sodium hydroxide. Well, now we use the mole ratio between iron chloride and sodium hydroxide in a reaction. Here you can see that 1 mole iron chloride reacts with 3 moles sodium hydroxide. It means that the mole ratio between these reactants is 1:3. I mentioned the mole ratio, 1 mole iron chloride, and in the bottom we have 3 moles sodium hydroxide. We write the mole ratio in such way so that we could cancel sodium hydroxide. Now we can do the calculation. Mole sodium hydroxide are cancelled. We multiply the top numbers and divide it by bottom one. In the top we have 0.855, it is already in the calculators, and it is divided by 3. This is the value we get, 0.285. Here we have 0.285. These are the moles of iron chloride required in the reaction. Well, now we compare the moles of iron chloride. These are the moles of iron chloride given in the problem, and these are the moles of iron chloride required in the reaction. When we compare these numbers, you can see that 0.263 is smaller than 0.285. It means that we are given less number of moles of iron chloride, but we need more number of moles of iron chloride. Thus, iron chloride is a limiting reactant. Well, we are done with the third step. Now we move on to the fourth step, that is to calculate theoretical yield. Well, theoretical yield is nothing but mass of any of the product in the reaction. Here, if we look at the question, it says that calculate the theoretical yield of any of the products found in the reaction. It does not specify one particular product for which we have to calculate the theoretical yield. That's why we randomly pick up one product. Let's say we calculate the theoretical yield for iron hydroxide. Well, when we calculate the theoretical yield, we always pick up the limiting reactant to calculate the mass of one of the product or any of the product produced in the reaction. Since iron chloride is a limiting reactant, we start with the moles of iron chloride given in the problem. Well, here we have the moles of iron chloride, that is 0.263. I mentioned here 0.263 and moles iron chloride. Now we calculate the moles of iron hydroxide produced in the reaction. For this step we use the mole ratio. Here you can see that 1 mole iron chloride produces 1 mole iron hydroxide. It means that the mole ratio is 1:1. That's why I mentioned here 1 mole iron hydroxide, and in the bottom we have 1 mole iron chloride. Since we are going to calculate the moles of iron hydroxide, we put the moles of iron hydroxide at the top, and mole iron chloride will cancel out. Now we convert the mole of iron hydroxide into mass. For this step we use the molar mass. Well, molar mass of iron hydroxide is 107 gram, and here we have iron hydroxide, and it is divided by, here we have 1 mole iron hydroxide. Well, Mole iron chloride will cancel, iron hydroxide will also cancel. We do the calculation. In the top we have that is 0.263 and it is multiplied by 107. This is the value we get. In the bottom we have 1, that's why this value will remain same. Now we write this value with 3 significant figures. 1, 2, 3 up to 1 we have 3 significant figures. We look at the digit next to 1, that is 4, and 4 is smaller than 5. That's why we round off these figures. Here we get 28.1, remaining digit become 0. Here we have 28.1 gram, and this is the mass of iron hydroxide produced in the reaction, or in other terms we can say this is the theoretical yield of iron hydroxide. This is how we calculate the theoretical yield, by following these 4 simple steps. Thank you.